Welcome to AI Frontiers, the cutting edge of computer science learning. Today we explore breakthroughs in AI efficiency, transparency, and adaptability. This presentation covers AI model optimization, continual learning, interpretability, and generative models, based on July 2025 research. Imagine a smartphone that predicts your next move before you think it. Current AI breakthroughs are making devices smarter, leaner, and more transparent. This isn't just about raw intelligence, but AI that explains its reasoning like a student showing their work. Today's research brings us closer to this reality. Computer science learning represents the art and science of teaching machines to learn from data efficiently and effectively. Key challenges include model size reduction, preventing catastrophic forgetting, ensuring transparency, and overcoming data scarcity. The papers we'll examine today tackle these issues head-on. Think of computer science learning as a bustling metropolis. In one district, engineers focus on making AI faster and cheaper, like converting a supercar to an electric scooter. Theorists work to understand why neural networks forget, similar to a chef burning dinner when trying new recipes. Bridge builders like TorchAO move AI from labs to daily applications. Our first research theme, model optimization. The AI diet plan. TorchAO achieves weight quantization, squeezing numbers into smaller containers like storing milk in pint cartons. Ternary networks take this further, using only 1, 0, or +1 values, like a light switch with no dimmer. Surprisingly, these sparse models compete with their bulkier counterparts. Research Theme 2 addresses continual learning and catastrophic forgetting. AI's language class problem. Liu et al. Used the Neural Tangent Kernel to understand forgetting patterns. Their solution gives AI a sticky note system for key patterns, preventing mistakes like saying gracias in French class after switching from Spanish. Interpretability, our third theme, provides X-ray goggles for AI. Li et al.'s Semantic-Aware Gaussian Processes act as lie detectors, with models rating confidence layer by layer, like students showing their work. Isgandarov's team combines isolation forest with explanations for trustworthy medical AI applications. Key findings from today's research include TorchAO's 2x speedup by baking quantization into PyTorch itself. Prabodesai et al. Demonstrated diffusion models excel in low data settings. Hydra's knowledge graphs prevent dead ends in drug discovery by maintaining logical connections between facts. Our paper of the day, TorchAO, the AI Efficiency Revolution Manifesto. The team addressed a critical problem. Models trained with high precision were being crudely compressed for deployment. Their solution uses tensor subclasses to tag data types, enabling seamless precision conversion throughout the AI pipeline. TorchAO's real-world impact spans from Instagram recommendations to on-device medical diagnostics. Early failures occurred when quantization disrupted LLM attention scores. The breakthrough came from recognizing some layers, like watch mechanisms, must remain precisely tuned while others can be simplified. A technical deep dive into quantization reveals how AI models are squeezed into smaller spaces. This process reduces numerical precision, from 32-bit to 4-bit, with minimal accuracy loss, comparable to compressing HD video for mobile. TorchAO's innovation lies in smart precision mixing for optimal results. Future directions envision AI as a gardener, pruning useless branches through sparsity, planting in low-data environments, and labeling through interpretability. Projects like GeoEngine's bake physics laws into neural nets for hurricane simulation. TinyML could enable Fitbits to train models overnight without cloud dependency. In conclusion, today's research makes AI both powerful and practical. Small enough for pockets, trustworthy for medical use, and efficient for sustainability. Breakthroughs in efficiency and transparency are creating machines that learn and explain more like humans. This presentation was synthesized by GPT DeepSeek using Model DeepSeek Chat with TTS via DeepGram and image generation by OpenAI. While human experts reviewed the content, some oversights may exist. All references are provided for further exploration. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by Archive Preprint Server.